In this problem, we have been given that AB is parallel to YT and this AB is parallel to YT and AC is equals to CY. So C is the midpoint of AY and OB the center of the circle. We have to find out the value of this angle X. Let's extend this YT line. Now this is the extended YT and draw AM perpendicular to MY and CP is perpendicular to MY and also draw CN so that CN is parallel to MY. Since C is the midpoint, so we can say that P is the midpoint of MY or CP is equals to half of AM. And we can clearly see that AM is the radius of this circle. So CP is equals to half into R. So by intersecting chord theorem, we can write Ty multiplied by AY is equals to this Ty is the tangent, so Ty square. So by simplifying, Cy into AY is 2 times Cy. So this is Ty square, or you can say Cy square is, and this Ty is My minus Mt. So this My minus Mt square, which is equals to My minus Mt itself is R. So this is R square, or My minus R is root 2 times Cy. Now we have this Cy is equals to My minus R over root 2. From triangle AMY, this triangle AMY, by using Pythagoras theorem, you can write AM square plus My square is equals to Y square, or AM, which is equals to R square, plus My square is equals to AY. AY means 2CY, so just 4. Or by simplifying, you can write by putting the value of 2CY square. So 2CY square is My minus R square is R square minus 2 times My into R, or you can say R square plus M square is equals to 2 times minus 4 times My into R, by you can write N square minus 4 times MYR plus R square is equals to. So we have a quadratic expression or a quadratic equation of My. So by using quadratic formula, we can find the value of My, so that My is equals to 4R plus or minus 16 R square minus 4R square over 2, which is equals to 4R plus or minus 2 root 3R over 2R. So there are the two possibilities of My, which is equals to 2R plus root 3 times R, or 2R minus root 3 times R. So now here is an important point that we cannot accept both roots of my. So you have to check which one is geometrically possible. Now, previously we know that Cy is my minus r over root 2. So we can check the value. Let Cy is my minus r over root 2. So put the value of my 2r minus root 3 times r. So this 2r minus root 3 times r minus r over root 2, which is r minus root 3 times r over root 2. So you can see that this value is less than 0, but this length Cy cannot be the negative, so this value is not valid. So we have to take the my as 2r plus root 3 times r. So Cy is equals to 2r plus root 3 times r minus r over root 2, which is equals to r plus root 3 times r. Now, if we see this triangle CPY, we can apply the sine x formula. So simply sine of x, which is equals to CP by CY. So let's write it. Sine of x equals to CP by CY. And we know that CP is r by 2. This r by 2. And now the CY is equals to r into root 3 plus 1 over root 2. By simplifying, we can write as root 2 over 2 root 3 plus 1. Just multiply denominator and numerator by root 3 minus 1. So 2 into root 3 plus 1 multiplied with root 3 minus 1. This gives us root 3 minus 1 over 2 times this is 2. So this is equals to this root 2. So root 3 minus 1 over 2 root 2. Now, if we look into this expression, sine of x equals to root 3 minus 1 by 2 root 2. And we also know that sine of a minus b is equals to sine of a into cos b minus cos a into sine b. So if we rearrange this term as the standard value of sine and cos, we can write the sine of x is equals to root 3 by 2 root 2 minus 1 over 2 root 2, which is equal to 1 by root 2 times root 3 by 2 minus 1 by root 2 into 1 by 2. Now, we know the standard value of sine theta and cos theta. So you can put the value sine of 45 degree, and this root 3 by 2 is cos of 30 degree minus this 1 over root 2 is cos of 45 degree, and half is sine 30 degree. So you can write this term as sine of 45 minus 30, which is equals to sine of 15 degree. So finally, sine of x is equals to sine 15 degree. X is equals to 15 degree. So this is our answer. The value of x is 15 degree.